So we have sum and difference formulas. Jot those down. And then we want to be able to use those to find the exact value of the sine of 15. When they mean the exact value, or when they say the exact value of the sine of 15, that means that we don't want to have what? Decimal, because that never finishes, never repeats. We have to round it, and so forth. So we have to ask ourselves, what values do we know that we can use in order to get 15 degrees? We know sine, cosine, tangent of 0, 30, 45, 60, 90, and then the multiples of those, right? So what's a way that we can get 15 from 0, 30, 45, 60, 90? 45 minus 30, okay? So we're going to use this sine of u minus v with 45 and 30. 15 is 45 minus 30. That means that we're going to use the sine difference formula. Okay? So that means that we're taking the sine of 45 minus 30, and that will be the sine of, the u is our first value, so 45, times the cosine of v, which is our second value, minus the cosine of the first value, times the sine of our second angle. Then we either need our unit circle or our table to quickly recall what these are. Because using 0, 30, 45, 60, and 90, which are the only ones we were supposed to have memorized, and 120 and 150 and so forth, 135, how can we use those in some combination, adding or subtracting to get 15? We could have used 60 and 45. We could have said 60 minus 45 would have also gotten us the sine of 15. Absolutely. Okay. So sine of 45 we should know from memory, hopefully. Square root of 2 over 2. Cosine of 30. Square root of 3 over 2. And you can use these, look these up on your unit circle as well. Cosine 45. Square root of 2 over 2. And 1/2 for sine of 30. Okay. Now, your answer can be written multiple ways. I would be happy to accept square root of 6 over 4 minus the square root of 2 over 4. I'm happy with square root of 6 minus square root of 2 all over 4. Okay, they're equivalent. Those are all, these two are both acceptable as answers. Because what is the square root of 2 times 3? Right? And 1 times the square root of 2. And they have a common, no, it could be two separate fractions. It could be a mixed fraction here. As long as we don't have radicals in the denominator, I'm happy. Yes, sir. You're 15, but you're trying to find the sine of 15 degrees or the sine of pi over 12. We don't know that mentally. So yes, we're going to do this in radians as well. Okay. Everybody cool, good with this so far? We started with degrees though because they're familiar with to us and comfortable. Not really. It's just that you have to have those formulas available. I'm not going to make you memorize them. Okay. So next one. Oh, I didn't have my unit circle out there. Okay. So here's a cosine of 7 pi over 12. As Peyton was just saying, we know 30 is pi over 6, right? So if we had divided that, 30 by 2, take pi over 6 divided by 2, there's our pi over 12. So we have to find some way of using now our pi over 3 and our pi over 4 and our pi over 6 to, in some manner, get 7 pi over 12. Well, 3 and 4 gets me 12, right? Okay, 3 times 4 gets me 12. So we're going to do something in order to get 7 pi over 12. What is 7 pi over 12 in degrees if you want to cheat? 105, okay? And we also can use pi over 2, can't we? 90 plus 15 would get us that, wouldn't it? But 15 is not one that we know. Okay. What are other ways to get 105 with those values? 60 and 45 would get us 7 pi over 12, wouldn't it? Okay. What's 60 in radians? Pi over 3. And what is 45 in radians? Pi over 4. Common denominator, as some of you mentioned, was 12, right? I'd have to multiply this by 4 and this by 3 to have a common denominator of 12. So this would be 4 pi over 3 plus, or 4 pi over 12 plus 3 pi over 12 gets me 7 pi over 12. So now we're adding, and we're using cosine. Okay? So cosine, the adding formula for cosine of pi over 3 plus pi over 4. Okay? So we're going to use cosine of pi over 3 plus pi over 4. Okay? First one listed is the pi over 3. So we're going to take the cosine of pi over 3 times the cosine of pi over 4 minus the sine of pi over 3 times the sine of pi over 4. Okay, we had pi over 3. If I plus pi over 4, if I get a common denominator, I have to multiply by 4 in this case, 4 over 4, and 3 in this case. 4 pi over 12 and 3 pi over 12 gets me 7 pi. Okay. What is the cosine of pi over 3? 1/2. Cosine of 60, right? 1/2. Cosine of pi over 4? Yep. Sine of 60? And sine of 45, or sine of pi over 4? Okay. So we get the square root of 2 over 4 minus the square root of 6 over 4. You can leave it like that, or since they have a common denominator anyway, you can write them over one denominator. Okay. Your book at times will also say this is the square root of 2 over 4 times 1 minus the square root of 3. And that's okay too. Yes, the order, or no, in here, no, nope, doesn't matter. Because we're multiplying, we're going to get the same result. So if someone else had said cosine of pi over 4 plus the pi over 3, that's okay too. Yep. Great questions. All right. Exact value of tangent of pi over 12. So if we added pi over 3 and pi over 4 before to get 7 pi over 12, what are we going to do this time? Subtract. Do we want to take pi over 3 minus pi over 4 or the other way around? Pi over 3 minus the pi over 4 should get us pi over 12, right? Because we want this, if we multiply this by 4 to get our 12ths, and multiply this by 3 to get our 12ths, 4 pi over 12 minus 3 pi over 12 gets us 1 pi over 12. So in this case, we want to make sure we have our pi over 3 first. Okay. So tangent. We'll have the tangent of pi over 3 minus pi over 4. And this time the order does matter because we're not adding. Tangent of pi over 3 minus the tangent of pi over 4 over 1 plus the tangent of pi over 3 times the tangent of pi over 4. Unit circle, what's the tangent of pi over 3? Pi over 3 is a 60, right? Square root of 3. Tangent of pi over 2 is 1. Tangent of pi over 3, we said again, was square root of 3, right? And tangent of pi over 4. Okay. So this is where we want to make sure that we rationalize our denominator. Can't have a radical down there. So what can I multiply the denominator by to clear that radical? Radical 3 is going to put it back here and clear this one. Remember those complex conjugates? If we had something like 2 plus 3i in the denominator, what do we multiply that by to make it go away? The conjugate, right? 2 minus 3i. So what are we going to multiply this by? 1 minus the square root of 3i, or square root of 3. Okay, so 1 times 1 will be 1. Outside gets me negative square root of 3. Inside gets me positive square root of 3. And last is going to get me a negative square root of 3 squared. Okay. And then let's work on the top. 1 times the square root of 3. Square root of 3 times negative square root of 3. Negative 1 times 1. Negative 1 times a negative square root of 3. So negative 3 and negative 1 is a negative 4. Plus 2 square roots of 3. Negative 2. And since they're all even, let's divide everybody by that negative 2. Negative 4 divided by negative 2. 2 square roots of 3 divided by negative 2. There's our exact value. Math Olympics. Using all of our good stuff that we've learned thus far. Okay. All right. Oh, this is what, I'm sorry. Okay. Now, two sections here. Okay. Blue is what we're doing today. We'll combine that with the black, which is what we're doing tomorrow. Okay. Two-day assignment.